The last video showed that different parts of the Earth heat up differently, with the equator receiving more radiative heat from the sun than the poles. And the purpose of global circulation is to redistribute this heat. If the Earth did not rotate and was a simple landmass with no oceans, we would have a single circulatory cell in each hemisphere, where hotter air would rise at the equator and flow toward the poles. The air would sink as it cools and then return towards the equator. But the unequal distribution of land and ocean and the speed of the Earth's rotation make this circulation system more complicated, giving us a three-cell pattern which exists in both the northern and southern hemispheres. The largest cells are the Hadley cells. At the equator, the warmer, less dense air rises. It rises to a height of about 18 kilometres and spreads out underneath the tropopause. The tropopause acts as a lid to the lowest part of our atmosphere, which contains all of our weather. The warm air spreads out towards the poles, gradually cooling and sinking as it moves, before descending to the surface and flowing back to the equator. The smallest cells are the polar cells. Cold, dense air descending in the polar regions flows at low levels to about 60 to 70 degrees north or south. As the air leaves the polar regions, it starts to warm and rise, returning to the poles at high levels. Between the Hadley and polar cells are the Ferrel cells. Unlike the other cells, the Ferrel cells are not driven by temperature. These cells flow in the opposite direction to the Hadley and polar cells, acting like a gear. These circulating cells not only transport heat from the equator to the poles, but also result in semi-permanent areas of high and low pressure due to the rising and descending parts of the circulation cells, giving us our climatic zones. Where air is rising, an area of low pressure is created, so these areas see much more rainfall. This is why the largest areas of rainforest are found near the equator, and why the United Kingdom has a relatively wet climate. Where air is descending, an area of high pressure forms, giving largely clear skies and little rainfall, which leads to the desert regions. But not all deserts are hot. Antarctica sits under the descending branch of the polar cell and is also classed as a desert. With more precipitation falling in the Sahara, Antarctica is the largest and driest desert overall. Check out our video on atmospheric pressure for more on how pressure leads to weather. Our next video shows how the rotation of the Earth gives us jet streams and prevailing winds.